Hello, this is Pat Kelly.
In this problem, they ask us to find a vector-valued function, that's going to be this r of uv for me, whose graph would be the indicated surface. So in this problem, that surface that they give me ahead of time is a cylinder with this equation, x squared plus y squared equals 25. Okay, here we go. Each one of these is going to be a different type of problem, hopefully similar thought process if it helps you at all, but you really just have to try to find your x and your y and your z in terms of these parameters u and v. Okay, so the real bulk of my work is going to be to figure out what x will equal and what y will equal and what z will equal in terms of u and v. For this particular problem, what I would notice maybe to start is that there's no z. Z is not connected to the x's or the y's here, which means to me mathematically that z can do whatever it wants. So we're going to let z equal one of the parameters. That way, whatever v is, that's what z is, and I have to be sure that it has no play on x and y. So the next part of my thought process is if I want to get a handle on x and y, I need them to be dependent on the same parameter, the other parameter u, or I need to tie into that v that's already here, because I don't want to introduce a second parameter and then also a third when I go to get my x and then my y. So we're only looking for a u and a v, and I know ahead of time that I'm not going to end up tying back into this v, because if I were, I would have seen a z in this equation. Okay? So that's telling me, I'm just kind of trying to share my thoughts with you, is that I'm going to get x and y, each of them dependent on the same parameter, the same variable. How do I do that? That's what's going to differ in each problem that you do. But for this one, what I'd be trying to recognize maybe is, hey, that's a circle, right? This is one of your circular relationships between x and y. So I'm thinking polar coordinates again. Okay? Polar coordinates where the radius is 5 and that's fixed. So that allows me to go right into a r cosine theta, but my r is 5. And see how x depends only on theta, and I have a corresponding y for polar coordinates of 5, that's the r, times sine theta. Okay, good. So that's what tells me then that x and y both depend on this theta variable. And all I'm going to do to get my final answer, I'm ready already, so my final answer, I'll just put theta in as u, and then my v I already have ready to go, so my vector-valued function is going to be 5 cosine of u times the I vector plus 5 sine of u times the j vector, and then plus v times the k vector. And that's it for this one. Okay? Practice some more on your own. Don't get frustrated. Keep trying different things and different problems. I'm sure you'll do well.